Math 2, 10.3. Today we are talking about evaluating radical expressions. So I wanted to show you here is that when you have a number, like 1 squared is 1 and the square root of 1 is 1. 2 squared is 4. The square root of 4 is 2. 3 squared is 9. Square root of 9 is 3. And so on and so forth. Oftentimes with square roots, you can look for the perfect square in order to find the answer. Okay? But sometimes things are not perfect squares. And we've actually worked through a lot of this before. So for instance, with the square root of 18, what would we do to find this answer? We want to break it down into like a factor tree. Okay? So what two numbers multiply to be 18? 9 and 2. And I would use 9 and 2 because 9, we know, is a perfect square. 9 breaks down to what?
3 and 3.
So we have a pair of 3s with a 2 left over. Do you guys remember how to write that?
Nope.
It's 3 root 2. So anything that has a pair gets brought out to the front of the root. Anything that doesn't have a pair or a group stays inside. So I always box it because it's like it's going to stay underneath the box in the root. If you had multiple groups of numbers, you would multiply them together. If you had a number in front, you'd multiply that number with the number in front. Okay, what two numbers multiply to be 72?
8 and 9.
Good. 8 times 9 works. Now 9 we know is 3 and 3, which makes a group. 8, instead of breaking it down to 4 and 2, and then 2 is 2 and 2, I just know that 8 is 2 times 2 times 2. Are we all okay with that?
Yeah.
And so for 8, you could do 3 little things if you wanted to, but it's 2 times 2 times 2. So I have a pair of 2s and 1 2 that does not have a group. Do you notice how there are 2 groups here?
Yes.
So each of those groups you end up multiplying together. So I have a group of 2s, so we take the number 2, and a group of 3s, which is the number 3, and we multiply that, it makes
6.
So the answer is 6 root 2. What would I break down 99 to?
11 and 9.
Good. And then 9 is 3 and 3. So I have a pair of 3s and an 11 left over. Now, do you notice how there's a 2 in front? So we just multiplied 2 times my group of 3s. So 2 times 3 makes 6 root 11. Questions before we move on and have letters in there too? We're good? Okay, number 4. Now, remember how if it's basically like if I have the square root of 3 squared, the answer is 3. What happens is that like you have a square root and this power of 2 kind of cancel out and you get 3 for your answer. You know, the same thing, the square root of 4 squared is 4. So what do you think the square root of x squared is? X is correct. Now, the long way is if you wrote down x times x, see how you have a pair of x's? That just makes x. Okay? The shortcut is that anytime you have a square root of a number squared, it just becomes that number. Now, if you notice in 5, and I'm going to do it the long way, and then I'm going to show you kind of a shortcut, okay? So the long way would be we'd write out 4 x's, 1, 2, 3, 4, and then I'm going to write out 6 y's, 1, 2, 3. Okay. And because they're square roots, we need 2 for a group. So I have 1 group, 2 groups of x's, and then when we go through the y's, I have 1, 2, 3 groups of y's. So how do you think I write that answer? So if there's 2 groups of x's, that's going to be x times x, which makes x squared. and there's 3 groups of y's, and so when you multiply y times y times y, that makes y to the third. Okay? That is the correct answer. Now, I'm going to show you the way that I normally work this out to save myself time. So, since I know I need 2 for a group, I just write this out as x squared and x squared. Because 2 plus 2 makes 4. Then for the y's, I'm going to go 2, 4, 6. So again, I have these all grouped, but I'm not having to write everything out. Does that make sense? And then here I still have 2 groups of x's, x squared, 3 groups of y's, y to the third. Okay. Do you have questions before I move on? Yes. You can do it that way too. As long as it makes sense to you, but I'm going to show work this way. Yes. Instead of writing it out long ways, I'm just showing you a shortcut. So from now on, I'm going to do the shortcut. Or you can divide it. But you have to be careful of leftovers. Okay. So on example 6, if I'm writing this out, I have 2, 4, and then I'm going to have 1 x left over. Because that makes 5, right? So I have 2 groups, and I have 1 left over. For the y's, I have 2, 4, 6, 8, and then 1 makes 9. So I have 1, 2, 3, 4, and 1 left over. So how will I end up writing this answer? X squared, y to the 4th, and then we have our root, and you have an x and a y left over inside. Okay, do we have any questions there? Okay, moving on to example 7. Hi, Hannah. So I'm not going to do it. Okay. Could I just give you a receipt later?
Yeah, I was
Okay. Okay, this one now you have letters and numbers. So, 36 would break down to what?
6 and 6.
Very good. And then for x to the 4th, I'm going to go x squared and x squared. There is nothing left over. What will be my answer?
6.
Very good. 6x squared is correct. Questions?
Well, she's asking why would you put the square root
Because there's nothing left over to go in the root. Okay. 24. What numbers does 24 break down to? Okay, we can do 6 and 4. And then 2 and 2, so I have a pair of 2s. You could do 8 and 3. That will also work. I'm not going to break 6 down because what 2 numbers multiply to be 6? 2 and 3. Is that going to give me any more pairs? No. So it's not worth the time. Does that make sense? And so I can go ahead and just box this 6 because I know that's going to be left over inside. If you did 8 and 3 and went through that way, you would end up with a 3 and a 2 left over inside. And you'd multiply them together and you'd still get a 6. Okay, how am I going to write out x to the 7th? Good, 2, 4, 6, and then 1 left over. So I have 1, 2, 3 groups, and 1 x left over. So how will I write this answer? And I try to do my circles and boxes, so I know all my circles get moved outside, all my boxes stay inside. So it's a way of me organizing my information so I don't get confused. 2x, how many groups are there of x's? Good. 2x cubed and then root 6 x. Good. Okay, questions. All right, try 9 on your own. I'm gonna give you about 30 seconds. You can do this. Okay, once you get your answer, check in your groups. I'm not going to be able to make it around to everybody. Okay, the correct answer is 8x to the third y root 3xy. How many got it? Uh-oh. Okay, let's go through this. Okay, what numbers multiply to be 48?
6 and 8.
Okay, we'll go with 6 and 8. Now, 6 breaks down to 3 and 2, and we know 8, we can just write that as 2, 2, and 2. Is everybody good with that? Okay, so I have one pair of 2s, and another pair of 2s, and a 3 left over in terms of numbers. Now let's move on to the x's. How will I write those? So since I have 5, I'm going to go x squared, so that's 2. Another x squared makes 4, and one more x makes 5. So notice that when you add those, it makes the 5. I'm just separating them to help make groups. So I have one group, 2 groups, and one group of x's left over. Okay, with the y's, how will I write that one? 1y squared and a y. Does that make 3? Yes. So I have one group, one left over. So far, so good? Okay, now pay attention because there are numbers in front there. So I already have a 2, and then I'm going to multiply it by this 2, which makes 4, and this 2, which makes 8. So that's where I got the 8 from. I already have one x here. This makes it x squared, and then x to the third. So I have 2 groups of x's that get brought out here, and the 2 plus the 1 that's already there makes x to the third. How many groups of y's? 1, but there's no y's out here, so it's just y. And then root, I'm going to go and find all my boxes, and that goes inside my root. So we have 3xy that goes inside. And that is how I got my answer. Does anybody want me to go through any of that again or re-explain anything?
How'd you get 8 again?
So for the 8, you have this 2, and each group just represents a 2.
Oh, okay.
Right? And so you have basically 3 2's that you're multiplying together. Any other questions? Okay, moving on to number 10. Notice on this one, it's not a square root, it's a cube root. Do you know what that means?
No.
Madison? Exactly. That means that you need a group of 3. So if this had a 5, how many would I need for my group? If this was a 5 right here,
5.
I would need 5. Okay? So anytime there isn't a number, it's a square root and you need 2 for your group. Okay? Anytime there is a number, that's how many you need for a group that gets brought out in front. So, what am I going to break 8 down to? We know that 8 breaks down to 2, 2, and 2. Is that a group of 3? Yes, so I have to have 3 to make a group. But that group, when I bring it out, just represents what? It just represents a 2, like one group, 1, 2. Okay? So each group, when it gets pulled out, represents one of those numbers. Now, how do you think I should write x to the 6th? Am I going to count in 2s? No, I want to count in 3s. Okay? And if it was a 5 here, I'd want to count in 5s. Okay. I'm going to write this as x to the 3rd and x to the 3rd. Is 3 plus 3 6? Yes. It is. So how do you think I'm going to write this answer? Is there anything that's not in a group?
No.
No. So that means there's going to be no root left over. And how will I write this answer?
2x.
Very good. 2x squared. Okay. We're good?
Yeah.
Okay. So number 11. What do we notice about number 11? It's cubed, so that means I need how many for a group? 3. Okay, how can I break 16 down? Okay? Sure. Either way, 8 times 2 or 4 and 4. I'm going to go 4 and 4 right now. But that's not helpful because I need, stop, 3. So that's 2 and 2 and 2 and 2. So I have 3 2s and 1 left over. Okay, what am I going to do with x to the 5th?
x3 and x2.
Good, x3 and x2. So I have one group of 3s, but I'm not going to put a circle around the 2. I'm going to write a square because I need 3 in order to make a group. And I only have 2 there, right? So that's going to stay inside. Do we understand that we need 3 of the same numbers in order to make a group that goes out?
Yeah.
So 3 plus 2 is 5. I have one group with 3 x's, but I have 2 x's that don't make a group. So it has to stay inside of the group. Okay, and how will I break up my y to the 9th? 3, 3, and 3. When you add those together, 3 plus 3 is 6 plus 3 makes 9. Everything ends up making it into a group. There aren't any y's left over. Now we have to write this answer. How do I write it?
2x.
Oh, and you know what I forgot? Does anybody know? I forgot one little thing.
You forgot the 2 on the cube.
The cube that goes, and it goes in this root there. Okay? Because otherwise, if I didn't have that 3 there, it looks like I could take out a group of x's, doesn't it? Because you'd think it's a square root. So if it's a cubed root, you have to make sure you write the cubed root. So let's just make sure we understand. I had a group of 2's, which makes this a 2. I had one group of x's, which makes this just an x. I had 1, 2, 3 groups of y's, which makes y to the 3rd. These boxes were left over, so I have to write the cubed root, and 2 was left over, and x squared was left over. Do we have questions? Okay. We need to now talk about rational and irrational numbers. Okay. Rational numbers can be written in the form a over b. So basically, it can be written in the form of a fraction. Okay? A rational number is a real number that can be written as a simple fraction, a ratio. Okay. So, for instance, the number 1.5 is a rational number because you can write 1.5 as a fraction as 3 over 2. If you go down here, 7 is a rational number because it can be written as a ratio 7 over 1. Okay? 0.333 that's going on and repeating forever is also a rational number because it can be written as a ratio of 1/3. Okay? Let's turn the page. Now we have irrational numbers. So an irrational number is a number that cannot be written as a fraction. Okay? A real number cannot be two numbers dividing. Okay? So the decimal goes on forever without repeating. Can you guys think of any numbers right now that are irrational numbers?
Pi.
Pi. Very good. Okay? Oh, that was right there.
I wasn't even
Almost
kidding.
surprised.
Okay. Also, any number that's under a square root, if it can't simplify, it is an irrational number. I just want to show you here. Let's do the square root of 2 because that can't be taken out. Do you see how like there's nothing repeating there? So some square roots are rational because if I had like the square root of 25, that answer when you simplify it is the square root of 25 is 5. So that's a rational number. But if you have a problem like here on example 1, do you see how you still end up with a root in your answer? That is irrational. Okay? So if you have a root in your answer after you've simplified, that's irrational. So all we're going to go through is name these if they're rational or irrational. And guess what we're going to do? We're going to use an R for rational and an I for irrational. I know, it's crazy. Okay, so number 1, what is that?
Irrational.
Very good. Number 2, irrational. Good. Yeah. Number 3,
Rational.
is there a root still in the answer once it's simplified?
Yeah.
Irrational. Okay, number 4,
Rational.
rational. Because it wouldn't matter any number I put in there, the square root of something squared ends up becoming that number. So this is rational. So anytime you eliminate the root, it's rational. Okay, what's 5 going to be? Rational, very good. 6. Very good. Why is 6 irrational? It still has a root. Very good. What about 7?
Rational.
Very good. 8.
Irrational.
Rational.
9 is? 10 and 11.
Irrational.
Very good. Okay, do we have any questions?